Welcome to Algebra 1, Chapter 4, Section 5, Writing a Function Rule. Vocabulary is rule. A mathematical rule is a method or procedure that describes how to solve a problem. An example of this is the rule of integer multiplication. A negative integer multiplied by a negative integer produces a positive integer. Another common rule you have is when dividing fractions. When we divide fractions, we multiply by the reciprocal. So which one of these is the example of this rule? Can you pick it out? If you pick this one, you are correct. So according to this rule, when we look at 2/3 divided by 6/9, we get 2/3 divided by, and then we're going to use a reciprocal of the second. We're going to use 9/6. And the reason this rule states that B, C, and D cannot equal 0 is because B, C, and D all end up in the denominator. And in a fraction, that fraction bar just means to divide, and you cannot divide by 0. We've been talking about function rules. When we say write y as a function of x, it means to write an equation where you can input values for x and you will get out values for y. Now the notation for writing this looks similar to f of x equals x plus 1. F of x is just a replacement for what you previously saw as y. Realizing that in function notation, f of x is another way of writing y. Do you know how you would read this out loud? It would be h of g. Looking at question number 2, we want to circle the equation that shows the function notation. So consider each of these. Which one shows the function notation? This is the one that shows the function notation. F of x equals 2x plus 1. On to question 3. Carmine wants to buy some peaches. Each peach costs 25 cents. Circle the function Carmine could use to find the cost of any number of peaches. Since we want the cost of peaches, we want the cost as a function of peaches. This is your correct answer. This one is not correct because there's no variable. A landfill has 50,000 tons of waste in it. Each month it accumulates an average of 420 more tons of waste. What is a function rule that represents the total amount of waste after m months? So we know that our total waste is 50,000 tons plus the additional 420 tons of waste each month. And that's going to increase each month. So we're going to multiply that by the number of months to get the total increase at the point. Let's let T equals our total waste, and that equals 50,000 plus the 420 each month. So our equation is T equals 50,000 plus 420 M. A kennel charges $15 per day to board dogs. Upon arrival, each dog must have a flea bath that costs $12. Write a function rule for the total cost of n days of boarding plus a bath. Then we will determine the cost of a 10-day stay. Well, let's first let our T equal our total cost. And our total cost is a function of the number of days. I will have to pay $15 per day to board my dogs. So for n days, it's going to cost 15 times n. You also have to pay a $12 fee bath. So that's going to cost an additional $12 no matter what, no matter how many days you spend. So the formula will be 15 times n plus 12. This is my function. When n equals 10, assuming I'm going to be gone for 10 days, I want to know how much that will cost me. So t is going to equal 15 times 10 plus 12. That's 150 plus 12. And I'm moving to the right because I'm running out of space. Would be $162. So the cost for a 10-day stay is $162. In this example, we are looking at concert seating. And we have two types of seating. We have reserve seating at $25 a seat. And there are 120 seats. I know that because 10 rows times 12 seats. And then I have general seating at $10 a seat. In this case, there are 480 seats. 30 rows, 16 seats per row. So to find the total revenue, that's going to be my T, my total revenue, I'm going to have 120 seats times $25. That's how much money I'll make off those reserve seats. Plus, I have 480 seats times $10. But that's only if they all sell. Now, some of them might not sell. So if less of them sell, let's say S sells. So that's the number of seats that sell. So my function rule will be T equals 3,000, that's 25 times 120, plus 10S, $10 for each general seat that sells. Now, if I do get my maximum total revenue, that means that each of the 480 seats sell. That's when S equals the 480 that I need to equal. My total revenue would equal 3,000 plus 10 times 480. And so T would equal 3,000 plus 4,800, which is $7,800. Let's try problem 3. Write a function rule for the area of a triangle whose height is 4 inches more than twice the length of its base. Determine the area of the triangle when the length of the base is 16 inches. So using this information, we need to let h equal the height of the triangle and b equal the base. So our height is going to equal twice the base plus 4 inches. We're continuing on with the previous problem. And we know the formula is area equals 1/2 base times height. And we're going to substitute for h. Now what we're going to substitute is that 2b plus 4 because that's what h equals. So here we're going to write 2b plus 4. So we distribute this b in. So b times 2b is 2b squared. B times 4 is 4b. And now we distribute, as you see, the 1/2 in as well. So b squared plus 2b. That would be our simplest version of our area. Now find the area of a triangle when its base is 16. So we're going to have 16 squared plus 2 times 16 because we put 16 in everywhere that b was. 16 squared is 256. 2 times 16 is 32. Add them together and you get 288. So the area of the triangle is 288 inches squared. For this got it, we're going to graph the function rule from exercise 14. And you are going to state how you know that the rule is nonlinear. So the first thing we need to do is complete the table of values. Our formula is a equals b squared plus 2b. So b squared would be 1 squared, because our b is 1 right now, plus 2 times 1. Well, the area would be 3. Then we have 4 squared plus 2 times 4. 4 squared is 16. 16 plus 8 is 24. 7 squared plus 2 times 7. 7 squared is 49. 49 plus 14 is 63. 10 squared is 100, plus 2 times 10 is 20. That's 120. Now we need to plot those. Take a look. Our numbering is a bit different than the traditional, but notice how the intervals are still evenly spaced. That's very important. No matter what you number them, they have to be evenly spaced. And let's graph the ordered pairs BH. So we're looking at the pairs 1, 3, 4, 24, 7, 63, and 10, 120. So 1, 3 is going to be really tiny down here. 4, 24 is going to be, well, that's 15, so 24 is going to be about right there. 7, 63 is going to be a bit more. 763 is going to be right up here. And 10, 120 is going to hit this point. So your line is going to look like this. And notice it's not linear because it's curved. Here's another nonlinear example. We want to write a function rule for the area of a rectangle whose length is 5 more than its width. So its length equals the width plus 5. And we then determine what the areas of the rectangle when its width is 9. Well, what I'm going to do is I'm going to put this in where I see the L. So my area is going to equal width plus 5 times width. So my area is going to equal width squared plus 5w. And this will be my function rule. Now I want to know what is the area when the width is 9. So I'm going to take my formula, my function rule, and wherever there's a w, I'm going to put in 9. That's a 5. So area is going to equal 81, that's 9 squared, plus 5 times 9 is 45. Add them together, and we get 126, and it's feet, so it's feet squared. So the area of the rectangle is 126 feet squared. And we're at the lesson check. Pause the video, attempt to complete this, and then start the video again and check your answer. It relates a square areas to its side length, continuous or discrete. Well, a continuous graph is unbroken, and a discrete graph is consisted of isolated points. Since the number of possible values for the length of the side is infinite, the graph must be continuous. So the graph is continuous. And it's that way because the length of the side could be any non-negative value. And since the graph should contain all those numbers that are between the whole numbers as well as the whole numbers. Try for yourself that you understand what function notation is, what a function rule is, and then rate how well you can write function rules.